Hello, this time looking at the time response questions. Level 0 just to get started. What time constant does this circuit have? Well, the time constant of an RC network like this is just the resistance times the capacitance, so that would be 68K times 47 pico, 3.2 microseconds. Done. Next. Just as easy, it doesn't really matter which way round the components are, the time constant is still the resistance times the capacitance. We just done that one. Right, here we have to measure the time constants. Now the trick here is to remember the magic number 63%. In one time constant, a first order response like this should have got up 63% of its total height. So the total height here is 211 millivolts or so 63% of that would be about 133 millivolts. So where is it 133 millivolts? Answer, about 490 microseconds. So 490 microseconds, close enough. Next, another one. Here we've got to get up to 5.58 volts, and 63% of 5.58 volts is 3.5. So 3.5 is about there at 76.6 microseconds. 77, probably close enough. Yes, great. Another time constant one. 220 times 150. Boom. Actually, it's a bit different. Which trace shows the step response of this given circuit? Right. Well, this is a low-pass filter configuration. So if you think about what's going to happen, immediately a step goes on A, so A jumps up from 0 to 1 volt. Well, the capacitor would not instantly charge up. It would remain at about 0 volts, and then it would slowly charge up as the voltage flows through this resistor to charge up this plate of the capacitor. Net result, the output at X would start low and would charge up towards 1 volt as this capacitor here charged up with the current flowing through this resistor. And there's only one curve here which has that shape, and it's A. So, answer must be A. Here we have a capacitor between A and X and a resistor down to ground. So if A suddenly shoots up from 0 to 1 volt, the voltage across the capacitor cannot change instantly. That's the thing about capacitors, you can't change the voltage across a capacitor instantly. So if the point here shoots up from 0 to 1 volt, the point here must shoot up from 0 to 1 volts right at time t equals 0 as well. So at time t equals 0, we would expect X to shoot up to 1 volt, and then to gradually decrease down to ground as the charge on this plate of the capacitor slowly leaks away through this resistor to ground. So we'd expect the time constant to have a shape like B or C. It would shoot up to 1 volt and then gradually come down. Is it B or C? Well, for that we'd have to work out the time constant. The time constant is 33 nano times 100K, which is 3.3 milli. So which one goes down by 63% in 3.3 milliseconds? Answer, quite clearly, it's B. C goes down much faster than that. So the answer must be B. And so on. I think those are the only types of question at level 0.